GMAT all day!
In this next set of videos, we will be talking about quadratic equations. Quadratics are pretty straightforward. You really only need to know two things when it comes to quadratic equations. Well, three things, actually. You need to know how to recognize quadratic equations. And then once you recognize that you have a quadratic equation, you need to know how to factor them. And then you also need to know how to FOIL or distribute them. And so for this first video, we will review how to do those things. And that should be all you need to know to get through the rest of the videos. So quadratic equations, in terms of recognizing them, they usually take this generic format: ax squared plus bx plus c, where a, b, and c are constants. And so a and b, these are coefficients, and then c is just another constant. Oftentimes, the a will just be equal to 1, so your quadratics will really just sort of look something like this, which is fine, but they don't have to. So they can give you a coefficient here, a leading coefficient that isn't equal to 1, and when they do that, that makes them a bit harder to factor. So it is actually a bit uncommon, and we will focus mostly on quadratic equations that look like this. But it is possible that you can have a quadratic equation with a leading coefficient, and maybe I will make a bonus video at the end of the series about how to factor quadratic equations when they give you ones with leading coefficients. But like I said, that is somewhat uncommon. I've not seen it much. And so when you have quadratic equations, they can present them to you in two formats. They could present them to you in the distributed form. And so that is when it is all multiplied out. So these on the left are quadratic equations in their distributed form. And then on the right, we have quadratic equations in their factored form. And if they give it to you in one of those forms, it probably means that you are going to have to convert it to the other form. And so let's start here on the right by doing just that. So here we have quadratic equations that are in their factored form. And so we want to FOIL them. And the reason I want to start here is because FOIL is actually an acronym telling you exactly how to multiply out your terms in order to distribute this factored quadratic equation. So FOIL, it stands for first, outer, inner, last, is exactly how we are going to multiply out our terms. So first we multiply our first terms. So that would be x times x, and that will give you x squared. Then will be plus our outer terms. And so that would be x times our negative 5. So that would be negative 5 minus 5x. And then we got to multiply our two inner terms. So that's our 4 times our x. That will give us a plus 4x here. Cross these off as we go. And then we got to multiply our two last terms. So that's our 4 times our 5, which is just negative 20. So when we combine this, this should, in our distributed form, give us x squared minus x, or minus 1x if you want to keep the coefficient, minus 20. So now let's look here on the left, where we have a quadratic equation that is in its distributed form, and we want to factor it. So if we sort of reverse engineer what we did here, so you can see what we did. So first, we're starting with an x squared here. It'd be easy to see. Then we need an x here and an x here. Then we had a negative 20 here, which we got. That was just the product of our two, the second terms in each of our parentheses. And then the coefficient for our middle term was just the sum of these two numbers. So we need two numbers here that multiply to negative 36, but sum to positive 5. And so if you we're just thinking of two numbers that will give you a product of negative 36. So one time, go through them one by one. 1 times negative 36, 2 times negative 18, 3 times 12, so on and so on. Then eventually you should see that 9 times negative 4, so positive 9 times negative 4 comes to multiplies to negative 36 and sums to positive 5. And so that is what this would look like. Now, in addition to showing how to factor and how to distribute these guys, so when is this useful, especially when is factoring useful? Well, it's useful when you have quadratic equations that are set equal to 0. And so if possible, it's usually a good idea to get your quadratic equations equal to 0, because once your quadratic equation is equal to 0 and you factor it, then it is very easy to solve for your possible values for x, sometimes called your roots for this equation. So in this case, x could be equal to -9 or +4. And those would be our roots for this equation here. So let's do another one here where we FOIL out a factored quadratic equation. So this would be x squared, then -2x, then -8x. And then we have -8 times -2. So that would be +16. So this would give us x squared minus 10x plus 16. And then here, let's factor this guy here. And let's do the same thing. Let's say this is set equal to 0 and then solve for our roots for x. And so if we need two numbers that multiply to 21, it looks like our choices are pretty much only 1 and 21 and 7 and 3, or -7 and -3. And so I think that is our guy here. So x minus 7 times x minus 3, because -7 plus -3 is -10, and -7 times -3 is +21. And so in this case, x could be equal to 7 or 3. Here in the bottom right, now we have an example of a factored quadratic that is going to give us a leading coefficient. So in order to distribute this or FOIL this, it is the same as before, same instructions. And so you should be able to do that with no problem. And so in that case, this would be 2x squared plus 2x times 3, which is 6x, plus 1 times x, which is x, plus 1 times 3, which is just 3. And so this would give us, in its distributed form, of 2x squared plus 7x plus 3. Now, what's a little bit harder is if they gave you this format, and then you had to factor it back to here. And so you can, if you just sort of reverse engineer what we did here to distribute this and reverse engineer it step by step, you can sort of come up with a way of factoring these. But like I said, I'll try to make a bonus video at the end, but this is less common that you have to do this because it's a bit less intuitive. One thing you can always do is just sort of test out all your possibilities. So we still need, for example, here, we know that the product of our two n terms has to be +3. And so based on that, our only choices really for what our factored form could look like are, you can either have 2x plus 1 times x plus 3, or you can always have the reverse, so 2x minus 1 times x minus 3. Then we can also have 2x plus 3 times x plus 1, or 2x minus 3 times x minus 1. And so in order to figure out which one of these is right, you would sort of have to multiply these all out, see which one of them gets you back to here. And if you're unsure of how to factor these quadratics with these leading coefficients, you can always just sort of try trial and error until you get one that works. But like I said, it is not super common that you have to do that on the GMAT. So that is factoring and FOILing. This is the basis for everything that we will be doing in this set of videos. So know how to factor, know how to FOIL, know how to do them backwards and forwards.